So my name is Lynn Soreghan, and I'm a geologist, a professor of geology here at the University of Oklahoma. I study what you might call, or what we call, deep time climate. So that's paleoclimate, trying to reconstruct climate of Earth's past from a long, long time ago. I look at, in this case, dust deposits. They're now rocks. They're now basically what you might call a siltstone or a mudstone. But under the right circumstances, we can interpret them as having been dust deposits, and we can extract paleoclimate information from them. You can just see times when the world is dusty and times when the world is less dusty. Paleosol, by the way, is a word that means fossil soil. So when you have times of soil development, it means that you kept the dust away long enough to develop a soil. That in and of itself is a climate change. But then you can delve a lot deeper. You can look at the particles of the dust and trace them back to their source, and by that be able to reconstruct the winds. That is, reconstruct atmospheric circulation. Which way did the winds blow? You could look at the size of the particles and determine basically the velocity of the wind, how fast, how hard the winds were blowing. You can look at magnetic properties of it and reconstruct precipitation. You can look at the character of the fossil soils, the geochemistry of the soils, and reconstruct atmospheric carbon dioxide. No one had a thermometer from, a million years ago. We don't have meteorological data recorded from hundreds of thousands of years ago. But what we have are sediments, and these sediments record attributes that can substitute for temperature, precipitation, wind velocities. This is a rock from Colorado from 300 million years ago. This surface has a lot of what appear to be little holes on the top, or they're not holes, but just circular spots. Those are actually raindrop imprints. This surface records a moment in time. In this case, it records a weather event that happened 300 million years ago, some afternoon. But then this, the rock itself, the centimeter or so that you see here, records the climate of Colorado 300 million years ago, when it was at the equator. When we're looking at deep time, we're looking at really what you might call alternative planetary states. Okay, we're trying to understand, when we look at climate from so long ago in the past, is we're trying to understand the range, the full dynamic range of Earth's climate system. How far can we go? How cold did it get? How hot did it get? How fast did it happen? So we're trying to understand the boundaries of Earth's climate system and how it really works.